So, welcome in next lecture of Math F242. So, in last class, we have started this model third. In this, we have single item, static demand, production model with back ordering. In this, we have considered the constant delivery rate A and constant demand rate with the condition A should be greater than D. Following are the assumptions for this model. So, already we have studied this assumptions. So here in last class I have told you that we can break one order cycle in the 3 time period or 4 time period, right? So here we have the T1, here we have the T2, here we have the T3, and here we have the T4. In the T1 to T2, in the T1 to T2, we have we manage the shortage we manage the shortages, right, with the production run and satisfying the current demand. In this case, in this period we manage the positive inventory level by satisfying the current demand. After reaching the maximum allowable capacity, we just use the stocked inventory, right, on the demand. And here we have the decrement of the inventory level. Here we have the decrement of the inventory level in the period T3, and in the period T4 again we are logging the back orders. We are making the record of the back orders. So this is the T1, T2, T3, T4. So in this case we can see in the T1 we manage the back order with the rate A minus D. A is the production rate, D is the demand. So we manage the back order with the rate A minus D for the period T1. So here it will become the A minus D into T1 is equal to B, which implies T1 is equal to B upon A minus D. Similarly, during the T2, we accommodate, we collect, right, we store S items in the period T2 with the rate A minus D. Means after satisfying the current demand with the delivery rate A, we able to stock the S items. So here the T2 will come S upon A minus D. Similarly, for the period T3, we have only the demand D, in which we utilize the collected S items, the stored S item through the demand. So here we have the D into T3 is equal to S, or T3 is equal to S upon D. Similarly, for the period T4, we collect the back orders. We collect the back orders which generates through the demand. So it B is equal to D into T4, or T4 is equal to B upon D. And total period we denote as T0 is equal to T1 plus T2 plus T3 plus T4. Now in this case, here you can see whatever the quantity you have generated in this period, whatever the quantity you have generated in this period, the complete quantity you are utilizing. So here we have, from where we have started, here we have end. So total production, that is the Q quantity, is equal to total quantity is equal to whatever you have produced, that is equal to the whatever the demand we have in this period. So D into T naught. And this quantity you have generated only in the period of T1 and T2. The same quantity you have generated in the period T1 to T2. So this Q will become the arrival rate or delivery rate into T1 plus T2. In the period T3 and T4, we are only utilizing. So from here, from the first and second, we have the B plus S is equal to A minus D into T1 plus T2. From here, if you see, so from here, B plus C will come B plus C will come A minus D into T1 plus T2. So from there, S can be written as A minus D into T1 plus T2 minus B, right? Minus B. And here, this S can be written as, and from here, from here, we know that T1 plus T2 is equal to Q upon A. So that Q upon A, when we put here, you have S is equal to 1 minus D upon A into Q minus B. After that, we have started to compute the holding cost. So holding cost, you know, in the when we have the positive inventory level, when we have positive inventory level, then only we have to we have to incur the holding cost. So here you can see in the period T2 and T3, because we have the positive inventory level, so here we have to bear the holding cost, right? So holding cost will come, holding cost, this is the holding cost. It is the C1, where C1 is unit holding cost, integral from 0 to T2 plus T3 in of IT. IT is the inventory level. Inventory level will increase with the delivery and will decrease with the demand. So IT means it is continuously changing. So IT into DT. So we break this integral into the two integral depending over the range 0 to T2 and T2 to T2 plus T3. So in this case, in the period of T2, you are able to generate the S item. So rate of generation will become S upon T2. And in the period T, how many items you can generate, you can stock. So that will become the into T. So S upon T2 into T will give you the inventory level. Inventory level. So 0 to T2 S upon T2 into T dt plus C1 integral T2 to T2 plus T3. Here the rate is, because you are utilizing the complete S item in the period T3. So rate of utilization or rate of decrement of inventory is equal to S upon T3 into, now what is the time, T2 plus T3 minus T dt. Means here we are we are seeing what is the level at the particular time. Uh, if you say, let's see, it is the T time, or it is the T time, it is T time. So at this time, what is the inventory level that we are managing? If it is the T time, so at that time, what is the inventory level that we are? So at this, we have the T and IT. Here we have the T and IT. So after doing the integration, we will get S is equal to T2 plus T3 into C1 upon 2. Last time we have derived this, and after putting the value of T2 and T3, we have holding cost as a C1 into Q into 1 minus D upon A minus B whole square upon 2D into 1 minus D upon A. So this much we have discussed in last class. Now we have seen, we have three type of the cost: procurement cost, holding cost, and the shortage cost. So holding cost, we have seen how we can write the holding cost. Now next is the total production cost. So total production cost in one run, so it includes the setup cost. Setup cost is independent of the quantity ordered. So it is the setup cost K plus C naught Q, plus C naught Q. So C naught Q means it is the purchase cost. So here you can say that it is setup cost and this is the purchase cost. purchase cost. So the sum of these two will be the procurement cost, right? So it is the procurement cost. Now here we compute the back order or shortage cost. You can say the shortage cost. So shortage cost we compute because you have seen here we have the shortages in the period this T1 and in the period T4. So as we have done for the T2 and T3 when we have the positive level, when we have the positive inventory, right? In the similar fashion, we do for the negative inventory. So instead of here we have the S, now here we have the B. Here we have the B. So using the same methodology, here you can see the holding cost is coming as a S into T2 plus T3 into C1 upon 2. So in the similar fashion, it will come it will come B into T1 plus T4 into C2 upon 2, where C2 is what? It is a unit holding cost. So when we have the shortage cost as shortage cost as B T1 plus T4 upon B is equal to T1 plus T4 into C2 upon 2 into C2 upon 2. This is the holding cost. Now from here we can see that T1 is equal to B upon A minus D. Right? From here we have T1 is equal to B upon A minus D, and from here T4 we have B upon D. So when we put the value of T1 and T2, so this will become B. T1 is B upon A minus D plus T4 is B D into C2 upon 2 upon 2. So here you can take B common, and inside we have A minus D into D plus A minus D into C2 upon 2. So here D and D cancel out. So when we divide it um, by the A, so this can be written as B square D upon, not B square C2 B square C2 upon 2D into 1 minus D upon A. This we can write. Clear? Any doubt in driving this? So it is the B square into C2 upon 2D into 1 minus D upon A. Yes, any doubt? Who is asking? Some doubt? Now, so from here, the total cost will be, from here, total cost will be the procurement cost, procurement cost plus holding cost plus shortage cost plus shortage cost. So procurement cost will come K plus C naught Q, that we have derived. Procurement cost will be K, this is the procurement cost K plus C naught Q. shortage cost is b square into c2 upon 2d into 1 minus d upon a. So this will become shortage cost as b square c2 upon 2d 1 minus d upon a. This is the shortage cost, and the holding cost we have derived. Holding cost here we have derived as c1 into q 1 minus d upon a minus b whole square upon 2d into 1 minus d upon a. That is our holding cost. So when we write here, it will become c1 um, k plus c naught q plus c1 q and q into 1 minus d upon a minus b whole square upon 2d 1 minus d upon a plus b square c2 upon 2d 1 minus d upon a. At that place I'm not able to write. I do not know what is happening there. So it is the procurement cost plus holding cost plus shortage cost. That is our total cost. So now this total cost is the function of q and right. This is the total cost. So it is the function of, you can say that this is the total cost, and it is the function of the q and b, where q is what, it is the quantity how much we should order, and b is what, it is the back order when we should order. These two questions always we have to answer in case of the inventory management. So here q represent the quantity, how much we should order, and b when we should order, means what should be the inventory level when we should order. So and during the derivation we have seen what is the t naught. T naught is q upon d, right. T naught is what, q upon d. So if you compute total cost, total cost per unit time, total cost per unit time, so it will become TCU, the function of Q and B, that is the TC of QB upon T naught. That is the total cost per unit time. So when we put, it is the TC upon Q into D. Q into D, that will come. So our expression will become K, right. K into D upon q, k into d upon q, plus this will become c naught d, and this will become c1 q into 1 minus d upon a minus b whole square upon this d is cancel out. Instead of the d, it will come 2q 1 minus d upon a, plus here we have the c2 b square upon 2q 1 minus d upon a. So this is our TCU. Now we want this TCU minimum, right? We want this TCU to be minimum TCU at Q star and B star. What is the optimum? What is the optimum level at which we should order, that we have to compute, and how much we should order? So for that we are using the classical differential and calculus theory, that at the optimum point the first derivative is 0. So here we first compute the del TCU upon del B, right? Del B. So it will give you, it is independent of B, it is independent of B, so that is 0. And here we have the derivative 2 C1 into Q1 minus D upon A minus B upon 2Q1 minus D upon A, and here we have the minus 1 plus 2C2B upon 2Q1 minus D upon A. And we know that according to classical theory in differential calculus, at the stationary point the first derivative should equal to 0, whether the maximum, minimum, or point of inflection, the first derivative is equal to 0. So here we have the this. So this can be written as 2 C1 into Q minus uh, Q, एक minute, Q is outside, it is 1 minus D minus A. So Q1 minus D upon A minus B upon, is equal to 2C2B. 2C2B. This will come. So it can be written as 2C1 2C1Q into 1 minus D upon A is equal to 2 C1 plus C2 into B. So here the 2 and 2 cancel out. So in this case, the B will come C1 Q 1 minus D upon A upon C1 plus C2. Right. So here we have the value of the B at which we have the stationary point. For the minimum, we have to check the second derivative. So del TCU upon del B2. Del B2, if you compute, so here we have the del TCU upon del B. So from here, when we compute the second derivative, so it will come 2C1. It will come 2C1 upon 2Q1 minus D upon A. 1 minus D upon A. And here from the second one, it will come 2C2 upon 2Q1 minus D upon A. So here you can see C1, C2 are the unit cost positive, Q is the quantity positive, A is greater than D, A is greater than D, that we have assumed. This implies 1 greater than D upon A. So this implies 1 minus D upon A is equal to positive. So when with this all the quantities are positive, then we say del del 2 TCU upon del B2 are positive. So you can say that at this b TCU is the TCU is minimum. So from here when we compute the value, so from here b is what? C1 into q 1 minus d upon a plus c1 upon c1 plus c2. So when we put the value of this b in the TCU, so now the TCU you will become the function of q only, that is the kd upon q plus c naught d plus, right? Here we have the TCU function, so it is equal to kd upon q plus c naught d into c1 into q minus d upon a minus b. In place of the b, just we put the value of whatever the value we have derived. So here we have the c1 q into q into 1 minus d upon a minus b. So b we have derived as c1 q 1 minus d upon a upon c1 plus c2, c1 plus c2 whole square upon 2q 1 minus d upon a plus c2 plus c2, and here we have the, it is the plus c2 into b square upon 2q 1 minus d upon a. So when we put the value of the b, so it will become 2c2, and here we have the c1 q 1 minus d upon a upon c1 plus c2, that is the b. Here we have the b square upon 2q 1 minus d upon a, d upon a. So this will give you, so this will give you kd upon q plus c naught d plus c1 q square 1 minus d upon a whole square upon 2q 1 minus d upon a into c2 upon c1 plus c2 whole square plus c2 plus c2 c1 square c1 square q q into 1 minus d upon a upon 2 into c1 plus c2 whole square. So here this q and q is cancel out, 1 minus d upon a 1 minus d upon a cancel out. So in this case the here we have kd upon q plus c naught d plus c1 c2 q 1 minus d upon a c1 plus c2 after taking the LCM, c1 plus c2 upon 2 c1 plus c2 whole square. So this can be written as, after taking the LCM, so this will become TCU q TCU q kd upon q plus c naught d plus 1 by 2 c1 c2 q 1 minus d upon a upon c1 plus c2. So this will cancel out. So this is the value of TCU in terms of the q, because we have to compute the optimal q star. So we compute here again, we apply the classical theory. So del TCU by del Q, because it is a function of Q. So del TCU Q by the del Q. So here the derivative of KD upon Q, KD upon Q is will become minus KD upon Q square. Second term is independent of Q, so 0. Then from the third term we have C1 C2, right? C1 C2 into 1 minus D upon A upon C1 plus C2. And we know that the first derivative for the optimal, it must be 0. So when it is 0, so here you have the Q square is equal to, Q square is equal to 2 KD, 2 KD C1 plus C2 upon 2 KD C1 plus C2 upon C1 C2 1 minus D upon A, 1 minus D upon A. So from here the Q will come root of 2 KD C1 plus C2 upon C1 C2 1 minus D upon A. That is our Q star. That is our Q star. And this Q star is what? It is the economic order quantity. Economic order quantity. Economic order quantity. This is the economic order quantity. Means this much is the quantity which we should order. This is the economic order quantity which we should order. Right? So after this, what will be the del TCU upon del Q2? First we have to check whether it is the minimum or not. So if you compute the del TCU upon del Q2, so here the derivative will come 2 KD upon 2 KD upon Q cube. From here it will come 2 KD upon Q cube plus 0. There is no quantity of the Q, so plus 0. So here you can see K is positive, demand is always positive, and Q is always positive. So this will give you, it is the greater than 0. That will implies that it here we have the minima. Here we have the minima. So from here, if you put the value of the Q star, if you put the value of the Q star in the TCU, in the TCU, so here you will get TCU, TCU, because in driving the Q star, we have used the optimal value of the B. So here we have the TCU Q star B star. So on putting the value of Q star, so here we have the C naught D plus KD upon Q. KD upon Q means root of 2 KD, root of 2 KD C1 plus C2 upon C1 C2 1 minus D upon A. D upon A plus C1 C2 Q, C1 C2 Q into 1 minus D, 1 minus D upon A upon 2 into C1 plus C2. 2 into C1 plus C2. Here we have the clear. This is the value of the TCUQ. So now at this Q also we have to put the optimal value. So in next line I am putting. So here we have the C naught D plus KD upon root of 2 KD C1 plus C2 upon C1 C2 1 minus D upon A plus C1 C2 root of uh, 2 KD C1 plus C2 upon C1 C2 1 minus D upon A into 1 minus D upon A upon 2 C1 plus C2 upon C1 plus C2. So just you put the value of the Q. So, so here you can see the root KD, you can cancel with the root KD, and here 1 upon D, it can be cancelled as a 1 minus root of 1 minus D upon A. So this can be written as C naught D, and here we have 2 KD, 2 KD C1 C2. This will go in numerator C1 C2 1 minus D upon A upon, okay, this 2 will not come in numerator, 2 into C1 plus C2 plus, here we have the KD C1 C2 1 minus D upon A upon 2 into C1 plus C2, 2 into C1 plus C2. So this can be written as C naught D plus root of 2 KD C1 C2 1 minus D upon A upon C1 plus C2. That is our TCU Q star B star. So that is the value of optimal cost. That is the value of optimal cost, right? This is the optimal optimal total cost, total cost per unit time, per unit time. And we know that what is the B? B is equal to, we have already derived C1 Q into 1 minus D upon A upon C1 plus C2. So if you put the Q star, if you put the Q star, so here you have the optimal B star. If you put the optimal value, so here you have the optimal B star, and Q star just now we have derived as 2 KD upon 2 KD into C1 plus C2 upon C1 C2 upon C1 C2 1 minus D upon A into 1 minus D upon A upon C1 plus C2. So from here, the B star will come, B star will come 2 KD, 2 KD C1 1 minus D upon A upon C2 C1 plus C2, C1 plus C2. So that is your B star. So B star is known as economic economic back order, economic back order quantity, economic back order quantity. Then we have the T naught star. T naught star is what? What is the T naught? T naught is the Q upon D. So that will implies that T naught star will be the Q star upon D. Q star upon D. So when we put the value of the Q star, value of the Q star as 2kd C1 plus C2 upon C1 C2 1 minus D upon A, that is our Q star, and upon D. So here the T naught star will come, T naught star will come 2k C1 plus C2 upon D C1 C2 1 minus D upon A. 1 minus D upon A. And I have told you that always we should go with the SS policy. So SS policy is what? Small s star, that is the minus B star, and capital S, at the time of the derivation, we have derived 1 minus D upon A Q minus B. That we have derived, right? So when we put the value of is optimal Q star and optimal Q star and the optimal B star. So here we have the 1 minus D upon A. Q means if you have to compute the S star, so this will become the Q star minus B star. So 1 minus D upon A Q star, we have the value root of 2kd upon C1 plus C2 C1 plus C2 upon C1 C2 1 minus D upon A. D upon A, that is our Q star, and B star is root of minus, it is the root of 2kd C1 into 1 minus D upon D, C1 1 minus D upon A whole upon C2 into C1 plus C2. C2 into C1 plus C2. So here we have the S star. So on solving, the S star will come, on solving, the S star will come 2kd 1 minus D upon A into C2 upon C1 into C1 plus C2. So actually, now please pay attention. Actually, what is happening when we compute? So here we have the time horizon at the optimal B star, or you can say S is equal to minus B star. We start our run. We start our run, and we start the production. So here the production will, inventory level will increase, and it increase up to the S star, up to the S star. Then after it will decrease, right? It will decrease and reach to the B star. So this time period is T naught star, and after the T naught, this graph will repeat. This graph will repeat. So that is the small s star. Small s star is equal to, small s star is equal to minus B star and capital S star. And in this run, optimum quantity you are ordering. Optimum quantity you are ordering. So here means this S star is what? This is the maximum maximum inventory level, right, or maximum optimal inventory level. And this T naught is nothing, it is the optimum order cycle order cycle optimum order cycle. So commonly we denote it by the OOC. And this is the economic back order quantity, we denote it by the EBO. And this is the total cost, and here we have economic order quantity, so it is commonly we call as a EOQ, right? So here we have, means first target is to compute the economic order quantity, EOQ. Thereafter we have to compute, because all are correlated to each other, so thereafter we compute the economic order quantity, economic back order quantity, right, or total cost, and the optimal order cycle. Means optimal order cycle means the length after which we have to repeat the reorder, that is the optimal reorder point, right, when we should the reorder. So that is the optimum order cycle. So that much for today. In next class we continue.
Hello.